Pure Math Unit 2 Paper 2 2025 May. So we'll just begin straight away. We'll begin with question 1, part A. Determine the equation of the tangent to the curve whose equation is, and we can see the equation there, and we're asked to find the equation of the tangent at the point minus 2, 2. But before we can find the equation of the tangent, we need to find the gradient of the tangent. So we need to differentiate this function, and of course it's an implicit function, so we have to find dy by dx, differentiating the function implicitly. So differentiate x to the 4th power, we multiply by the x power and subtract 1, so that's 4x to the 3rd power. Then negative 2xy is a product, so we'll treat the negative 2x as a function and treat the y as a separate function and apply the product rule. So product rule says we differentiate the first, so that's negative 2x. Differentiate negative 2x with respect to x, we get negative 2, and we keep the y, so we leave the y alone. Plus, we're going to alternate now. This time, we're going to differentiate the y, and the derivative of y is dy by dx. And then the other function, negative 2x, we'll leave that alone. Plus, differentiate 3y squared. We use a chain rule, so differentiate 3y squared, we multiply by the y power, and subtract 1 from the y power, so 2 times 3, that's 6, y to the power of 1. So, on the differentiate y, we get dy by dx, and the right hand side, the derivative of 0 is 0. Remember now, the aim is to find dy by dx, which gives the gradient. So we need to group all the terms with dy by dx. So I'll begin with this term, since it's positive. So that's 6y dy by dx. And this other term is a term with dy by dx. So it's minus 2x dy by dx, since the terms are multiplied. Doesn't matter the order. So I put the 2x at the front. And I'll group the other terms now on the right hand side. So negative 2y is now positive 2y, and 4x cubed group on the other side is now negative 4x cubed. So we're solving for dy by dx, so I can factor out dy by dx from each term. So factor dy by dx from the first term, where I'm left with 6y. From the other term, I'm left with minus 2x. Equal to the right hand side, 2y minus 4x cubed. And of course, to solve for dy by dx, I can divide both terms, both sides by a bracket, 6y minus 2x, so that cancels itself. Alright, so I'm left with dy by dx. And what you'll notice on the right hand side, I mean, all of these can be divided by 2, so we can reduce this equation, this right hand side, by dividing through by 2. So to divide 2y by 2, that's y. Divide 4x cubed, that's 2x cubed. And divide also the denominator by 2. 6y divided by 2, that's 3y. Minus 2x divided by 2, that's minus x. So that's the simplest expression we can find for dy by dx, and we need the gradient of the tangent. Alright, so it passes through the point minus 2, 2. So here x is negative 2 and y is 2. So we substitute these values into dy by dx. So we substitute x is negative 2 and y is positive 2. Alright, so replacing, so end up with dy by dx equal y, and y is 2, minus 2 times x cubed, and x is negative 2, so that's negative 2 cubed over 3 times y, that becomes 3 times 2, minus x, and x is negative 2. So if we should simplify this, let me do the denominator first. That's 3 times 2, 6. And the double negative gives us a plus, so 6 plus 2, that's 8. And in the numerator, what we have now is 2. And then this is negative 2 cubed. That's negative 8 times negative 2. That's positive 16. So 2 plus 16. So that's 18 over 8. Which should simplify. That's 18 over 8. And this should simplify to 9 over 4. So dy by dx is equal to 9 over 4. And we're being asked to find the equation of the tangent. So we have just found m, which is what dy by dx represents, the gradient of the tangent. So to get the equation, now all straight line takes the form y equal mx plus c. So equation of the tangent is tangent is a straight line, so it shall take the form y equal mx plus c. And remember, the point, the tangent passes through the point minus 2, 2. And we just found m to be 9 over 4. So we can substitute these values into y equal mx plus c to get a value for c. So replace y with 2. Replace m with 9 over 4. Replace x with, so the first value is x, second value is y. So replace x with minus 2. And we have our plus c. So solving for c. So we'll end up with 2 equal to, and then 2 times, well, negative 2 times 9 over 4. That will become negative 9 over 2 plus c. And then to solve for c, we can add 9 over 2 to both sides. So 2 plus 9 over 2 is equal to c. Now 9 over 2 is same as 4.5. So 4.5 plus 2, that's 6.5. So c is 6.5. Or 13 over 2, if I want to write it as an improper fraction. So that means, therefore, that the equation of the tangent is y equal mx plus c. But we know the value of m is 9 over 4, so 9 over 4 x. And we know the value of c is 13 over 2. So this would be our solution. Let's move on to part B. Calculate the square root of the complex number 2 minus 3. So let me just quickly do an Argand diagram for this complex number. Alright, so this is the real axis. And here's our imaginary axis, that's the vertical axis. So 2 minus 3, that's 2. On the horizontal, all the real axis. And minus 3 on the vertical, or the imaginary axis. So this would look like this. Alright, so we need to find, first let's put this complex number in its polar form. Alright, so let's find the modulus, or r, which is the distance from the origin to the point we plot there. And the formulas are the square root of 2 squared plus 3 squared. That's directly from Pythagoras theorem. So r would be square root of 4 plus 9. That's the square root of 13. That's r. And theta, that's the angle between the horizontal and r. This is r, the angle between the horizontal and r. So we can use the tan ratio. Tan theta is always the imaginary coefficient over the real. So in this case it's 3 over 2. Which means theta is tan inverse 3 over 2. Which is tan inverse 3 over 2. That's 56.31 degrees if I'm using 2 decimal places. But because of where the angle is located, you're moving to R, you're moving clockwise to the from the vertical axis, from the horizontal axis, sorry, to R. That means it's a negative angle. So actually theta would actually be negative. So this angle is actually negative 56.31 degrees. So theta is negative. So hence theta is minus 56.31 degrees. Since coming from the horizontal, you're moving clockwise to R. Alright, so we have R and theta, so now we are able to write the complex number in its polar form. It means therefore, so that 2 minus 3i, so remember the polar form of a complex number is R into cos theta plus I sin theta. So we just found R, so let's rewrite this complex number as R, and R is root 13, alright, into cos theta, and we just found theta to be negative 56.31 degrees plus I sin negative 56.31 degrees. Alright? And now we have been asked to find the square root of 2 minus 3i. So to get the square root of 2 minus 3i, we raise 2 minus 3i to the power of a half. Since raising a value to the power of a half is same as finding the square root of that value. So we raise the other side also to the power and a half, but we're using the Moivre's theorem. That's the Moivre's theorem. That's the theorem we're using. So we're raising, what we did, we wrote the complex number in its polar form, and then we're raising both sides to the power of a half. But the thing about the Moivre's theorem, what it says about raising the polar form of a complex number to a power, n in this case n is a half, so it's root 13, sorry, raised to the power of a half. So we raise r to the power of n, in this case half, and then the nth power n, we can always now multiply n, in this case half, times the angle, n theta. So what we have is cos times cos half of negative 56.31 degrees plus, motor space here, I sin n theta, in this case, would be half times negative 56.31 degrees. So what we'll end up with is 2 minus 3i to the power of a half, same thing as square root of 2 minus 3i. And we can work out now the square root of 13 raised to the power of half. So we take the square root of 13 and then the square root of that, and that should give us 1.9 in the bracket. We'll have the cosine of n theta, which is half times minus 56.31. So half of 56.31, that's minus 28.15 if I'm using 2 decimal places, plus I sin minus 28.15. Minus 28.15 degrees. Alright? So now we can, of course, expand our bracket. So what we have now is 2 minus 3i to the power of a half. So it's 1.9. So expand the bracket. It's 1.9 cos minus 28.15 degrees plus I. So distribute the 1.9 to each term in the bracket. So 1.9 sine negative 28.15 degrees. So 1.9 cost negative 28.15 degrees. That's 1.68 if I'm using 2 decimal places. And what we'll do is 3 decimal places. 1.675. 1.675 approximately. And then 1.9 sine negative 28.5. That's minus 0.896 I. Alright, so 2 minus 3I raised to the power of half is equal to this. So that's 1. So it's similar. So if I ask you what is the square root of 100, I mean, you think of which number you can multiply by itself to get 100, and that's 10. But it's also plus or minus 10, because 10 times itself gives you 100. Negative 10 times itself also gives you 100. So the full solution is the plus or minus of whatever we have here. Alright? Which means that it's 1.675 minus 0.896 I. Or if we distribute the minus the terms in the bracket, that's negative 1.675. Distribute minus to this, we'll end up with plus 0.896 I. Alright, so these represent the square root of the complex number 2 minus 3i. Alright, let's move on. Next, we are asked to differentiate sine inverse e to the x plus a over 3 with respect to x. So we're going to treat the a as a constant. So the rule for differentiating sine inverse, so we know there's a rule, that's if y equal to sine inverse u, it means that dy by dx is equal to u prime over the square root of 1 minus u square. So in this case, u is always what's in the bracket. So to find the derivative, we need u prime, and well, we already have u, so we just need to find u prime. So u prime is just is the bracket differentiated with respect to x. So let me rewrite u. I'm going to break up this as e to the x over 3 plus a over 3. Alright, so u prime is derivative, differentiate the first term, differentiate e to x, is just e to x over 3. Nothing changes, differentiate a over 3. Now a is a constant, which means a over 3 is a constant. So differentiate a over 3. There are any constant, you'll get 0. So we have u prime. So it means that our solution, alright, so if y equal to, so we're asked to differentiate sine inverse e to the x plus a over 3, and dy by dx is equal to u prime, which is a bracket differentiated. We just did it. That's 1/3 e to the x, or same as saying e to the x over 3, all over square root of 1 minus u square. So it's 1 minus a bracket square, and the bracket is e to the x plus a over 3 all square. And since we were not asked to simplify, we just leave it at that. Next, we're asked to integrate e to the 2x cos x, and of course we have a product of two functions, so we're going to apply integration by parts. Now the by parts formula, so I use this by parts formula, integral of uv dx. So this is the by parts formula. It's equal to the integral is u times the integral of v minus integral. Now this integral of v here, we repeat it in the second part, and then the other function, which is u, we differentiate it, so that's u prime. So that's our by parts formula. So I'm going to call the e to the x 2x u. I'm going to call the cos x v. Alright, so applying the by parts. So we leave the u alone, so that's which is e to the 2x. The other function we integrate, so integrate cos x, that's sin x, minus, I'll put our integral sign. Now u is e to the 2x, which means u prime is e to the 2x differentiated. So that's 2e to the 2x. I'm going to put it to outside here, 2e, and since it's a constant, I'll just put it outside here conveniently. And then the integral of v, we already have the integral of v. V is cos x, the integral of v is sin x. Alright, that's the first step. Let's go again. So continue. So on the left hand side, so what we have on the left hand side is the integral of, remember, e to the 2x cos x dx. On the right hand side, we still have a product here. E to the 2x sin x, we're going to integrate again by parts. So let me just restate. E to the 2x sin x minus 2, and I'm going to integrate the function again, applying by parts again. This time again, I'm going to call this u, the e to the 2x u. I'm going to call the sin x v, and repeat the same process as we did here. Alright, so u, that's e to the 2x, and the integral of sin x, that's negative cos x. So this time it's negative cos x, so I'll put the negative here, times cos x, minus the integral of u prime, and u prime again is u differentiated, so differentiate e to the 2x again, which is actually 2e to the 2x. We put the constant outside, times the integral of v. So the integral of v again is negative cos x, because v is sin x. The integral of sin x is negative cos x. So I'll have negative cos x, so it's cos x, negative cos x. So we'll end up with actually plus because of the double negative. So this term will be a positive term. Dx. Now let's expand the bracket. So on the left we have the integral of e to the 2x cos x dx equal to e to the 2x sin x. I'm going to distribute this 2. So negative times negative, I end up with positive 2 e to the 2x cos x, and then negative 2 times positive 2, so that's negative 4 times the integral of e to the 2x cos x dx. So now you can see that these are like terms. We have a term integral e to the 2x cos x dx, integral e to the 2x cos x. So we have one of them here. We're going to group this term on the left hand side. We'll actually have 4 e to the 2x cos x dx plus, so we end up with positive 4 integral e to the 2x cos x dx plus this one integral e to the 2x cos x dx, and on the right hand side we are left with e to the 2x, and let me just factor out e to the 2x here since it's common to both terms. So it's e to the 2x, and in the bracket we'll have sin x, and if I factor out e to the 2x from here, we'll have 2 cos x. So remember, the aim of the game is to find the integral of e to the 2x cos x. So we end up with 5 here, and then we can, so this is 5, this is actually 5, 4 plus 1, e to the 2x cos x dx equal to what we have here on the right hand side. right, which is e to the 2x into sine x plus 2 cos x, and then we can of course divide both sides by 5. Right, so we divide both sides by 5, divide by 5, and there we have an expression for the integral of e to the 2x cos x dx, which is what here we have on the right hand side. That's our solution. We are now at question 2. So show that the partial derivative of x, so differentiating sine kx squared y to the 4th power, where is a proof. We're asked to differentiate the function with respect to x. So it's a partial derivative, which means we're going to treat the y as a constant. So the rule for differentiating these string functions is to differentiate what's in the bracket, in this time with respect to x. So in other words, we're going to multiply by the x power and subtract 1 from the x power. So 2 times 3, that's 6 x to the 1st power, and of course y to the 4th power, and of course sine will now become cos, and of course what's in the bracket does not change. So what we have essentially done is find the partial derivative of the function, of course with respect to x. Let's move on to part 2. Given that the partial derivative with respect to y is equal to, and we are given 12x squared y cubed cos 3x squared y to the power 4. Now we can do this one of 2 ways. We are asked to find the second derivative with respect to y. So, I mean, this was not needed any at all, but we can differentiate. So, think about partial derivatives. With respect to y, then x is same as differentiating the function with respect to x and then y. So we could find this what I circle here by differentiating this function with respect to x, or we already differentiate the function with respect to x in part 1, so we can again differentiate this same function with respect to y. Either way, it doesn't matter. So here we have the derivative. They gave us the derivative with respect to y. So we can say that this is what we're asked to find. Partial derivative of the function sine 3x squared y to the 4th power over with respect to x and with respect to y. Alright. Now we have found with respect to x already, and we're also given with respect to y. So let's do this, differentiate this function with respect to x. So with respect to x, so we're going to use the product rule. So we're going to treat the 12x squared y cubed separate from the cosine 3x squared y to the 4th power. So applying the product rule, differentiate, and we're doing it now with respect to x. So 12x squared y cubed with respect to x simply means you're multiplying by the x power, you're subtracting 1 from the x power. So 2 times 12, that's 24x y cubed. I'm using the product rule, so I'll leave the cosine alone. That's cosine 3x squared y to the 4th power, plus, this time now I'm leaving the 12x squared y cubed alone, and then I'm differentiating the cosine now with respect to x, of course. So this time I'm multiplying by the x power inside here. That's 6x, well, negative 6x, and then y to the 4th power, and of course cos is now sine. What's in the bracket doesn't change. Alright, just to be a little bit neater, we can rewrite this as 24x y cubed cosine 3x squared y to the 4th power. And if we multiply these terms, 6 times 12, that's 72. X times x squared, that's x cubed. And y times y to the 4th power times y cubed, that's y to the 7th power. So add the powers there. Sine whatever is in the bracket, which is 3x squared y to the power 4. Just want to remind that the same problem could have been done by differentiating this function with respect to y. You'll end up with the same result. Now let's move on. Use partial fractions to show that. Alright, so we're going to so x squared plus 7 over x squared plus 3x plus 2. And of course, x squared into itself, that's 1. So we'll have 1 outside here. And then the factors now. If you should factorize x squared plus 3x plus 2. Now x squared plus 3x plus 2 factorize is x plus 1, x plus 2. So these will be our denominators. So let me put a over x plus 1 plus b over x plus 2. So our job is now to show that the value of a is 8 and the value of b is negative 11. So what we can do is times both sides. We can times both sides by the denominator there on the left hand side. Alright, just rewrite it using the factors x minus 1 times x plus 2. So we're going to multiply each term on both sides by these two brackets. So of course, if we multiply the left hand side, what will happen is that the denominator will cancel, leaving us with x squared plus 7. You multiply these brackets by 1, what you'll get is x minus 1 times x plus 2. You multiply these brackets by a, the x plus 1 will cancel. Well, x plus 1. X plus 1, so not x minus 1, x plus 1. The x plus 1 will cancel, leaving us with x plus 2. And if we multiply these brackets to b, final term here, the x plus 2 will cancel, leaving us with x plus 1. And then now we need to find the value of a and b, so we can substitute different values. So that will make the bracket 0. Let's try x equal negative 1. So if x is negative 1, on the left hand side what we have is negative 1 squared, which is 1, plus 7. On the right hand side, negative 1 here will make the bracket everything become 0. Negative 1 plus 1 is 0, so all of that will be 0. If we put negative 1 in the second in the a term with a, what we have in the bracket is actually negative 1 plus 2, which actually have a in the negative 1 plus 2, which is actually 1, which is 1a. 1 plus 7 is 8, so of course a would have to be 8. Now the other value that makes the bracket 0 will be negative 2. So if we let x be negative 2, what you have here on the left hand side is negative 2 squared, which is 4, plus 7. Plug negative 2 in this term here, you'll have negative 2 plus 2, which is 0. So all of that will be 0. Plug negative 2 in the term with a, you'll have negative 2 plus 2. All of that will be 0. In the final bracket now, negative 2, what you have is b. We have here negative 2 plus 1. So 4 and 7, that's 11. Negative 2 plus 1, that's negative 1. So that's negative 1b. Divide both sides by negative 1. So that's negative 11. So positive b is equal to negative 11, which is what you're asked to prove. That's a is 8 and b is negative 11. Alright, so we have just shown that. Let's move on. So we're asked to integrate this function here. Now we have just shown that this function is equal to, let us rewrite it, is equal to 1 plus 8 over x plus 1 minus 11 over x plus 2. Alright, so we just prove that this function is equal to this. So integrating this is equivalent from integrating the partial fractions. So the integral of 1, that's x, and we can use integration using recognition. Integrate 8 over x plus 1, integrating a constant over a linear function, that's just 8 ln x plus 1 minus 11, that's log a denominator, ln x plus 2. Remember the integral of 1 over x is log x. Alright, and remember your plus c, since it's indefinite integral. Alright, let's move on. Use the substitution x equal 4 sine theta to determine the integral of x over 16 minus x squared dx. So with all substitution, you always have to differentiate what you're substituting. So we're using x to be equal to 4 sine theta. So if we differentiate x with respect to theta, so dx by theta, differentiate sine, you'll get cos, right? So differentiate 4 sine theta, that's 4 cos theta. I'm going to separate it. The plan is to substitute all of this into the function here we're asked to integrate. So we need an expression for dx. So if we just cross multiply, dx is equal to 4 cos theta d theta. So we can replace dx with 4 cos theta d theta. Let's substitute. So rewrite this the problem. So x, we're told, is 4 sine theta. In the denominator, it's 16 minus x squared, and x squared would be, if you square both sides, x squared would be 16 sine squared theta. And dx is 4 cos theta d theta. So dx, that's 4 cos theta d theta. Let's try and simplify this now. So we know what we have up here is 4 times 4 is 16 sine theta cos theta d theta. So now we're integrating with respect to theta. In the denominator, I can factor 16. So I'm left with 16 into 1 minus sine square theta. Now, we know an identity that says cos square theta, the Pythagorean identity, plus sine square theta is equal to 1. So, which means that if I bring this over, that means cos square theta is 1 minus sine square theta. Alright? So 1 minus sine square theta can be replaced with cos square theta. By the way, 16 cancels 16, right? So what we actually have now is the integral of sine theta cos theta over 1 minus sine square theta, which is from there is cos square theta. And of course cos square theta d theta. So we can reduce even further. So cos square theta is cos times cos. So cos will cancel here, and we're left with, so what we actually have is sine theta over cos theta, which is d theta, and the integral of sine theta over cos theta, well, sine theta over cos theta, that's actually tan theta. Alright, and the integral of tan theta is negative ln cos theta, which can also be written as ln sec theta if you wish, but I'm going to use negative ln cos theta plus c. But remember we want the answer in terms of x. Now just remember that x equal to 4 sine theta, which means that x square both sides is 16 sine square theta. So if we want an expression for sine square, we can divide both sides by 16. So sine square is x square over 16. So we can replace sine square with x square over 16. Down here we can replace sine square with x square over 16. Alright, so cos square is 1 minus x squared over 16. But take the square root of both sides. Cos theta is the square root of 1 minus x squared over 16, which means that if in the final answer is negative ln, and for cos theta, we can substitute it for the terms next, which is the square root of 1 minus x squared over 16 plus c. And that's our integral. Let's move now to question 3. Use proof by induction to establish that. Alright, so first we need to establish at the base case. So we need to show through when n is equal to 1. When n is equal to 1, notice that the first term here is 1 times 3. Or you could use the formula here. Replace n with 1. We actually have 1 into 1 plus 2. So either way, on the left hand side, we'll have 3. And to get the summation, here on the right hand side, we substitute 1 for n. So what we have is 1 6 times 1, which is 1 6. Replace n with 1. 1 plus 1, that's 2. In the other bracket, replace n with 1. 2 times 1 plus 7, that's actually 9. So what we have is 3 is equal to, well, 2 times 9, 18. 1 6 of 18 is positive 3. So, statement is true when n equal to 1. The second step in this process is to assume it's true for n equal to k. So we're going to replace n with k everywhere. So on the left hand side we have 1 times 3, which is 3, plus 2 times 4. So the second term there is 8, plus that, plus, and then we replace n with k. So the kth term of the k times k plus 2. On the right, replace n with k everywhere. Just 1 6k, summing the first k terms, times k plus 1 over 2k plus 7. That's step 2. And the final step, step 3, is to show true for n equal to k plus 1. So continuing from step 2, this step is all about increasing the left hand side by an extra term. So again, let me start again. So 1 times 3 plus 2 times 4. And what you'll notice a pattern here. So the first term is 1 times 3. The second term is 2 times 4. And you can bet the third term would have been 3 times 5. Notice you're multiplying the first number here. The number in the bracket is actually 2 times more. Well, 2 more than the number outside the bracket. Alright, so if it here in step 2, our final term was k times k plus 2. So I'm going to add one more term to the left hand side. And the term that comes after k is k plus 1. And of course, you'll multiply k plus 1 by a value that's 2 greater. So add 2, that's k plus 3. And the right hand side now is a different thing going on. On the right hand side, you're summing up k plus 1 terms. So everywhere you have a k, you're going to replace k with k plus 1. So 1 6 times k is 1 6 times k plus 1. The second bracket, replace k with k plus 1. That's k plus 1 plus 1. That's k plus 2. And the bracket here at the end, currently we have 2k plus 7. We're replacing k with k plus 1. So 2 times k becomes 2 times k plus 1. And 2 times k plus 1, that's actually 2k plus 2. And if you add 7, that's actually 2k plus 9. So 2k plus 7 now becomes 2k plus 9, since you're replacing k with k plus 1. Now our job is to show that the left hand side is the same value. Well, same as the right hand side. And like in all induction proofs, we use back the identity from step 2. If you look at step 2, from 1 times 3 to k times k plus 2. So 1 times 3 to k times k plus 2. In step 2, all of this is equal to 16k. All of what I underline is equal to 16k. You substitute it times k plus 1 times 2k plus 7. And then we're left with the additional term, which was k plus 1 times k plus 3. Alright? So this is what we have on the left hand side. Let me put equal to. So let me put the left hand side equal to that, right? Well, let me just rewrite the right hand side. 16 times k plus 1 into k plus 2 into 2k plus 9. And as I said just now, we want to show that both sides are the same. So we can do it one of two ways. Either we can factorize both sides, or we can expand the bracket. So the right hand side is already factorized. I'm going to factorize the left hand side. But before I do that, I want to bring everything under a common denominator. 6, like the right hand side. So here, I'm going to put everything over 1. And to make the denominator 6, I can multiply numerator and denominator by 6, right? And put the 6 outside here. Good. So let me just focus just now on the left hand side. So LHS, abbreviating for the left hand side, right? The left hand side, right? So put everything over 1 common denominator, which is 6. Alright, so left hand side. And of course, I'm going to factor out, a common factor here is k plus 1. So I'm going to factor out k plus 1 from both terms. So k plus 1 factored. And if I factor out k plus 1 from this, what I'm left with is k times 2k plus 7. So I'm left with k times 2k plus 7. What is k times 2k plus 7? That's 2k squared plus 7k. And then come here, we're going to factor out k plus 1. So here we factor out k plus 1. We're left with k times 2k plus 7. Expanded, that's 2k squared plus 7k. I'm also factoring out k plus 1 for him. Here I'm left with 6 times k plus 3. And 6 times k plus 3, the 6 times k is 6k. And the 6 times 3 is 18. Alright, so let's fix it up and show that it's same as what we have on the right hand side. So let's continue. So the left hand side, so I have k plus 1 in the bracket. In the other bracket, if I group the like terms, so it's all over 6. If I group the like terms, what I have here is 2k squared, 7 and 6, that's 13k, group like terms, plus 18. Alright, and if you should factorize the quadratic there in the second bracket, so that's k plus 1. Or if we should factorize using the AC method or whichever method, this will factorize to what we have here. Right? K plus 2 times 2k plus 9. K plus 2 times 2k plus 9. That's what we'll get if you should factorize the second bracket. All over 6. Notice this is exactly what the right hand side is. Let me just RHS for right hand side. That's exactly what the right hand side is equal to. 1/6 k plus 1, k plus 2, 2k plus 9. So, therefore, statement is true when n equal k plus 1. And therefore true for all values of n, or for all natural numbers, for all n where n belong to the set of natural numbers. Part B, use the method of difference to show that, and we have to prove this. Now before we can use the method of difference, we first need to rewrite the expression there as partial fractions. So we're going to let 1 over r plus 4 well, into r plus 5. Let it be equal to a over r plus 4 plus b over r plus 5. And as we know with partial fractions, we're going to times both sides now by the factors on the left hand side here. So times both sides by r plus 4 times r plus 5. So r plus 4 times r plus 5 times the left hand side, that would cancel. Denominator cancel, leaving us with 1. Multiply these brackets by the term with a. The r plus 4 will cancel, leaving r plus 5. Multiply the term in b. The r plus 5 will cancel, leaving r plus 4. And then we're going to substitute brackets now that makes the values that makes the bracket 0. So we're going to let r be negative 5. I'm going to do b first. Let r be negative 4. So if I let r be negative 4, the left hand side is 1. If r is negative 4, what we'll have in the bracket here is negative 4 plus 5. That's 1. So that's 1a. So a is 1. And of course we can also let r be negative 5. If r is negative 5, again, the left hand side is 1. The first bracket will become 0. Negative 5 plus 5, that's 0. So that disappears. And here, negative 5 plus 4, that's negative 1. So negative 1b. Divide both sides by negative 1. So the value of b is negative 1. Which means we can rewrite the series. We can rewrite this. Alright, so let's rewrite. So sum of r equals 0 to n. So sum of r equals 0. Sum of the series from r equals 0 to n. And it is now 1 over, where does it jump to? 1 over r plus 4 into r plus 5. So 1 over r plus 4 into r plus 5. We can rewrite this as sum from r equals 0 to n as, so we got a to be 1 and b to be negative 1. So a, so it's 1 over r plus 4, negative 1 over r plus 5. So 1 over r plus 4 minus 1 over r plus 5. So we can try values now. Let's plug in. Let's begin with, so we start from r equals 0. So when r is 0, what we have is 1 over 0 plus 4. That's just 1 over 4, a quarter. When r is 0, what you'll have here is 1 over 0 plus 5, that's 1/5. Alright? That would be the first term. First term. Plus, let's do when r is 1 now. When r is 1, what you'll have is 1 over 1 plus 4, that's 1/5. When r is 1, 1 over 1 plus 5, that's 1/6. Now we can continue on and on. If we do when r is, so plus that. Let's do when r is, so these will be the first two terms. Let's do the last two terms now. So when r is, the second to last term will be n minus 1. When r is n minus 1, what we'll have is 1 over n minus 1 plus 4. That's 1 over n plus 3. When r is n minus 1, we'll have 1 over n minus 1 plus 5. That's 1 over n plus 4. And the final term is when r is n. When r is n, what we'll have is 1 over n plus 4. So 1 over n plus 4. And 1 over n plus 5. And what you should notice here is something nice happening now. What you should notice here is that these 1/5 cancel negative 1/5. And so on. This 1/6, negative 1/6 will cancel a 1/6 there. Alright? And so on. Everything will cancel. 1 over n plus 4 cancel negative 1 over n plus 4. So what you'll be left with is the first term, which is first value there is a quarter. And the last value there will be 1 over n plus 5. Minus 1 over n plus 5. Which is what we were asked to prove, right? A quarter minus 1 over n plus 5. Alright? Hence, or otherwise, calculate the partial sum S19. So S19, we simply substitute S19, you simply replace n with 19. So it's a quarter minus 1 over 19 plus 5. So that's a quarter minus 1 over 19 and 5, that's 24. And this should simplify to, use a calculator for that, 5 over 24. Now in question 3, we have just shown that the summation of the series here is equal to, we just showed is equal to a quarter minus 1 over n plus 5. A quarter minus 1 over n plus 5. Alright? And it's to infinity, so replace n with infinity. So it's a quarter minus 1 over infinity plus 5. Now 1 over infinity approaches 0. So we are just left with a quarter. And that's our solution. Okay, so now we are at question 4. Use the intermediate value theorem to show that f of x equal e to the power of x minus 5x has a root in the interval 2 to 3. So we do this by finding f of 2. So f of 2 will be e, replacing x with 2. So e to the 2 second power minus 5 times 2. We can just punch that in our calculator and we end up with minus 2.61094 if I'm using as much as 5 decimal places here. And f of 3 will be e cube, replacing x with 3 again, minus 5 times 3 this time. And you punch that in your calculator. And if I'm using 5 decimal places, I end up with 5.08554. So notice the signs are different. So since f of 2, which is a negative value, times f of 3, which is a positive value, and you multiply a negative value times a positive value, you will get a negative value. So it's less than 0, and then all negative values are less than 0, right? So therefore, by the, just abbreviate, the intermediate value theorem, abbreviating IVT, a root lies between the values 2 and 3. So we know the root would be 2 point something. Hence, or otherwise, use 3 iterations of linear interpolation to approximate the root of e of x minus 5 of x equals 0 in the interval 2, 3. Okay, so we have just demonstrated that the root lies between 2 and 3. And of course, we know that f of 2 gave us a negative value and f of 3 gave us a positive value. So now root lies between these because f of 2 and f of 3 give us different signs. So now the linear interpolation formula, we're going to use 3 iterations. So for the first iteration, I'm going to use x subscript 1. And the formula for linear interpolation, very easy to recall. So we have f of a, the modulus of f of a, plus the modulus of f of b, over, same thing, modulus of f of a, times modulus of f of b, well, plus modulus of f of b. And in the numerator, we just switch these. So this is b times f of a, and this is a times f of b. Now, where a and b would be the roots, so the root is between 2 and 3. So for now, a is 2 and b is 3. Alright, so substituting these, x1. So the value of b is 3. Now f of a and f of b we found already. We found f of 2 and we found f of 3. What were these values? So f of 2 was negative 2.61194, but we're using a positive value in the formula, the modulus, or absolute value. So f of 2 was, let me just restate it here, f of 2 negative 2.6094. And f of 3 was 5.08554. So b, replacing b with the upper limit, which is 3 times f of a, the positive value, f of 2, which is positive. So we're going to use a positive absolute value, 2.61094, plus a, and of course we're using a to be 2, times f of b. Alright, it's already positive, 5.08554, all over the sum of the two brackets, f of a and f of b, and we're using the positive values, of course. So 2.6094 plus, and a bracket, f of b, 5.08554. We can punch that in your calculator, and we end up with, what do I have here? Punch in the calculator, work it in one go, as it is, and we end up with 2.33924. That's the first iteration. In the first time we use the formula. Let's do our second iteration now. So this time now, but before we can do our second iteration, we need to have a new limit now. So we have just shown that now. We have just found between 2 and 3. Let's call this 2. So it's 2.339224. So we have found this to be a approximate root using the first iteration, or the first formula for the first time. Alright? So we need to determine if the root is between 2 and 2.33924, or is the root between 2.33924. So we need to find f of 2.33, f of 2.33924. Let's find f of 2.33924 and see what we have. So 2.33924, remember the function was e to the x minus 5x, so e to the 2.33924 minus 5 times 2.33924, and punch this in our calculator, and this will give us negative 1.32285. Alright, so f of this value give us a negative value. And don't remember that f of b, f of 3 also give a positive value. So notice f of 2 and f of this value, 2.33, both of them give us negative value. So the root is not between 2 and 2.3. So the root is between 2 and 2.339 and positive 3, since f of these values give us different signs. So we're going to move our a now. So our a is now this value. So when we're applying this formula, we're going to use our a for the lower value, 2.33924, and our b for a positive 3. So we're done with this side of the line. So these are our new limits now. So using our second iteration, we use the exact formula, but this time we have a different a value. Alright, the b value is still 3. So for here, b we use positive 3. F of a is f of 2.33924, which we had already found was 1. We're using the positive value, the absolute value. So we're using 1.32285 plus a is 2.33924. So 2.33924 times f of b, which was f of 3. F of 3 was what now? 5.08554. Same as before. Alright, 5.08554. All over the values in the bracket, f of a and f of b, the positive values. So 1.32285. 285 plus 5.08554. And if you punch that in your calculator, this will work out to x2 being 2.47564. That's our second iteration. We actually use 3 iterations. So let's use one more now. So, but first we need to decide at what is f of 2.47564. So f of 2.45764. Again, replacing the same function, e to the x. So it's e to 2.47564 minus 5 times 2.47564, and we'll get what we'll get now. Let's the calculator. We get negative 0. Stick to 5 decimal places. Alright, negative. So we'll get a negative value. So f of 2.47564, this was our second iteration. 2.47564. F of this, we get a negative value. So obviously now the root is between 2.47564 and positive 3. So of course we're going to have some new limits now. So of course now this is our a now. Alright, so now we're evaluating the roots between these two values, 2.47 and b, which is 3. So notice for this example, every new iteration, the value of a change, that's the lower limit, and the upper limit b remain the same. Alright, so we go again, this time using a to be 2.47564 and b to be positive 3y. F of these values give us different signs. So we use them as our two limits. Alright, so we're going to third and final iteration, this time x3. And we're using the exact same formula. Alright, so this time we're b, again the b is positive 3. And f of a is f of 2.47564, which we found to be negative 0.48889, but because we're using the modulus according to the formula, we use positive 0.48889 plus a, and a is 2.47564 times f of b, and f of b is still 3, so f of b is f of 3, and we already have that. That's 5.08554 all over f of a plus f of b, and we already have those. These are the values in the bracket. So f of a, that's 0.48889, and f of b, that's 5.08554. Punch this in our calculator, and our answer is 2.522. The idea is that the more iterations you use, the more refined and the more accurate your solution becomes. Alright, so we're actually use 3, so we leave it at that. Let's continue. Part B. Use 2 steps of the iteration formula. X subscript n plus 1 is 5 over x cubed minus 1 with x subscript 1 equal to 2 to estimate the root of this equation. X to the 5th power minus x squared minus equal to 25. So we have x1, so we need x2 and x3. So 2 steps. So the first step will be to get x2. Now to get x2 would mean that you need to replace n with 1. So replace n with 1. So if we let n be 1, that's how you get x2. 1 plus 1, 2. O equal to 5 over x cube subscript 1, x1 subscript cube minus 1. So this will be equal to 5 over the square root. Now we were told that x subscript 1 is 2. So x subscript 1, that's 2, so that's 2 cube minus 1. Alright, so that's 5 over the square root. Now 2 cube is 8, 8 minus 1 is 7. So 5 over root 7, which is, in decimals, 5 over root 7 is, using my calculator, that's 1.8898 if I'm using 4 decimal places. And so that's x2. Now, there's 2 steps, so we need x3. X subscript 3 would mean that you have to replace the n with 2. So if I let n be 2, this subscript will now be x subscript 2 plus 1. That's x subscript 3, replacing n with 2. So that's 5 over the square root of x subscript 2 cube minus 1. That's 5 over, now we just found x subscript 2 to be 1.8898, so that's 1.8898 cube minus 1. And we can put this in your calculator. So in your calculator, this will work out to 2.085 if I'm using 3 decimal places. Let's continue. Part C. Show that the Maclaurin series expansion of log sec x up to and including its first 2 non-zero terms is x squared. Well, I mean, the 2 separate terms won't have x squared, so I guess this should be x to the 4th power. This should be x to the 4th power over 12. So the formula for Maclaurin series is a function f of x is summation f of, so we have x to the nth power times the nth derivative evaluated at 0 over n factorial. Alright, let's differentiate. And so we know, so f of x, the function f of x is log sec x. So let's evaluate at 0. F of 0 then would be L log. Now sec 0 is 1. Sec is 1 over cos 0 is 1. So 1 over 1, that's 1. So log 1, and of course log 1 is 0. So this won't count as a term, because we're talking about non-zero terms. Alright, non-zero terms. So let's differentiate. So if the first derivative, differentiate sec x, you get sec x. So differentiate what's in the bracket, differentiate sec x, that's sec x tan x, and put the derivative over the original bracket, which is sec x. So differentiate ln sec x, what you got is tan x. And if you evaluate at 0, what you get is tan 0. And of course tan 0 is 0. So we still don't count these two values since we only want non-zero terms. If differentiate again, so this is the second derivative, differentiate now. To get the second derivative, differentiate the first derivative tan x, differentiate tan x, you get sec square x. Evaluate at 0. So what you get is sec square 0, and sec square 0 is equal to 1. Since sec square is 1 over cos square, and of course cos 0 is 1. Alright, so now we have a term. When we get the second derivative, let's find the third derivative now. To get the third derivative, you differentiate sec square x, and of course we're using the quotient, well, not the quotient rule, the chain rule. Look at sec x as sec x all square. We're going to look at sec x as sec x, look at it as sec x all square, right? So we're going to apply the chain rule. We'll multiply by the power, keep the bracket, subtract 1 from the power, and now differentiate what's in the bracket. Differentiate what's in the bracket, which is sec x, differentiate sec x, you get sec x tan x. And if we simplify this, this is 2 sec times x, that's 2 sec square x tan x. And if you evaluate at 0, the third derivative evaluate at 0, we know tan 0 is 0. So 0 times anything is 0, so that will be 0. Let's do the fourth derivative. Right, so fourth derivative. Of course, product rule. So we have sec square x, and we'll treat tan x separate, so product rule. So we're going to differentiate sec square x, which we just did. So derivative of sec square x, well actually, we differentiate now 2 sec square x. So differentiate sec square x. What we get was 2 sec square x tan x. But it's 2 times that. So it's actually 4 sec square x tan x. Times the other term, which is tan x. Plus, and then according to product rule, we're going to differentiate our tan x, differentiate tan x, that's sec square x times 2 sec square x. So that's sec square x times 2 sec square x. And now we're going to evaluate at 0. So the fourth derivative, evaluated at 0, we end up with tan 0. So all of this is going to become 0, because tan 0 is 0. And then we know sec square 0 is 1. So what we'll end up with is 2. Well, it will actually be sec to the fourth power. But sec x is 1. 1 to n power is 1. So it's just 2 we'll be left with. So now we can write our Maclaurin series. So remember Maclaurin series again. F of x is equal to the summation x to the n power f to the n derivative at 0 over n factorial. So we only have for this second and the fourth derivative. Well, for the second derivative. So in this case, n will be 2, so x squared, and then f second derivative evaluated at 0, so f2 would be 1, so x squared times 1, which is just x, over 2 factorial, which is 2, plus, at the fourth derivative now, is x to the fourth power, evaluated the fourth derivative was 2, so 2x to the fourth power, over 4 factorial, well 2 factorial here, 4 factorial. And that 4 factorial is 24. So what we'll end up with is x squared, well 2 factorial is 2, plus, this is 2 over 24, which is 112. So it's x4 to the fourth power over 12, which is what you're asked to prove, alright? X squared over 2 plus x to the fourth power over 12. So they made an error here, obviously. Alright? Alright, let's move on. Part D. Use binomial expansion to show that the square root of 1 minus x over 1 plus x is equal to or approximates to 1 minus x plus x squared over 2 if terms with the power 3 or higher can be ignored. So we only want the expansion up to the second power in x, alright? So let's rewrite. So what we have is the square root of 1 minus x over 1 plus x, which is equal to the square root of 1 minus x over the square root of 1 plus x, which is equal to 1 minus x to the power of half. So remember, I can rewrite square root as a value raised to the power of half. Right now, this in the denominator is 1 plus x to the positive half. But if I bring it up, it's now 1 plus x to the minus half. That's by rewriting it. Down here is positive half. Half indices, you bring it up, is now negative a half. Now remember the expansion. 1 plus x to the n power. 1 plus x to the n power is 1 plus, this is given on the formula sheet, 1 plus nx plus n times n minus 1 x squared over 2 factorial, and so on. But since we're only going up to the second power of x, then we'll stop here. Now let's expand the first bracket. Alright, in this case now, it's not x, is actually a negative x we have inside here. So when we expand, n is half, since the powers are half. So when we expand, it's 1, using this formula, plus n, and of course n is half, n is a power. But this time now it's not x, it's actually a negative x we have there. So half times minus x, plus n, which is a half, times n minus 1, so that's half minus 1, times x squared. So it's negative x, but negative x times negative x is positive x squared. So x squared over 2 factorial. That's what we have for the first bracket. 1 minus x to the positive half. Let's do 1 plus x now to the negative half. So in this case now, n is negative half. Alright, so same formula here. So it's 1 plus n is negative half. So nx will be negative half x plus n, that's negative half, times minus half minus 1 times x squared over 2 factorial. Alright? Remember, terms 3 or higher are ignored. So we're stopping at the second power of x. Alright, let's see if we can simplify. So let's see if we can simplify. So for the first bracket, what we have now is 1 minus half x. And then what we have here is half. Now half minus 1, that's negative half. So what we have is half times negative half. That's negative a quarter. Negative a quarter divided by 2. That's negative 1/8. So this is negative 1/8 x squared. In the second bracket, what we have is 1 minus half x. And again, for the second bracket, minus half minus 1. That's minus 3 over 2. That's minus 1.5 or minus 3 over 2. Times minus half. That's positive 3 over 4. And 3 over 4 divided by 2, that's 3 over 8. So that's 3 over 8, because 2 factorial is 2. So that's 3 over 8 x squared. Let's do the expansion now. So we take the 1 and times each term at the second bracket there. So 1 times 1, that's 1. 1 times negative half x, that's negative half x. And 1 times 3/8x squared, that's 3/8x squared. Let's expand now by the negative half x. So negative half x times 1, that's negative half x. Negative half x times negative half x, that's positive quarter x squared. Negative half x. And then negative half x times the x squared term. You get an x cube, which we don't want. So we don't need that term. Alright? Now let's do the negative 1/8 times x squared. So negative 1/8 x squared times 1, that's negative 1/8 x squared. And then negative 1/8 x squared times x, you get an x cube term, which you don't want. The terms 3, where the power is 3 or higher. Likewise, 1/8 x squared times 3/8 x squared. We don't want that term either. We're only doing the term up to x squared. Alright? According to the question. So let's group the like terms now. So we have 1, alright, minus half x, minus half minus half. That's minus 1, so that's minus x. Group the x squared terms. So there's 3/8 and this 3/8 plus a quarter, which is 2/8, so that's 5/8, minus 1/8, that's 4/8. So 4/8, same thing as half, right? So plus half x squared. And of course there are more terms, but we only want the terms up to, we're ignoring the power when it's 3 or higher, alright? So that's our solution we have there. Hence, by setting x equal to 1/8 in the binomial expansion of what we just did, estimate root 7. Alright? So we just showed that. The square root of 1 minus x over 1 plus x is equal to 1 minus x plus half x squared, approximately, going up to the power highest at 2. So let's replace x with 1/8 now. Alright, so let x be equal to 1/8. If x is 1/8, come here, in the numerator, we'll have 1 minus 1/8, which is 7/8. In the denominator, we have 1 plus 1/8, which is 1 and 1/8, that's 9/8. Alright, over here, replace x with 1/8. What we have is 1 minus 1/8 plus half times 1/8 squared. Alright, so it approximates to that. Now what we have now is 7/8 divided by 9/8. Let's work it out. So 7/8 divided by 9/8 is same thing as 7/8 times, and you flip 8 over 9. So that cancel. So this simplifies to the square root of 7 over 9 equal to, and then if we work this out, 1 minus 1/8 plus half 1/8 squared. Using my calculator, it simplifies the right hand side to 113 over 128. Alright. Continuing, this is same thing as root 7 over root 9. Just to break it up, equal to 113 over 128. But we know root 9 is 3, right? So this is root 7 over positive 3 is 113 over 128. So to get root 7, which is what we're asked to find, we'll multiply both sides by positive 3. So root 7 approximates to 3 times 113 over 128. So that's 339 over 128. And in decimals, it approximates to 2.648. Let's move on to question 5. Question 5. 2 of your dice are tossed consecutively, and the sum of the numbers that result is recorded. Let E be the event that the number on the first die is even, and let F represent the event that the sum is less than 9. Complete the table by writing down the possible outcomes of the experiment. Let's complete this table. So 1 plus 1, that's 2. 1 and 2, that's 3. 1 and 3, 4. 5, 6, 7. Next one, 2 and 1, that's 3. 2 and 2, 4. 2 and 3, 5, and so on. So it's a very easy table to complete. Only 2 marks for that. 2 and 4, 6. 2 and 5, 7. 2 and 6, 8. And so on. So now we have our table complete. What are we asked to do now? Calculate, it's a conditional probability. Calculate F given E, the probability that the sum of the numbers that result is less than 9. That's what F represents. And E represents the probability that the first die is even. So it's a conditional probability. So F given E means that we already know that the first dice is even. The number on the first die is even. So the first die, here it is. Alright, in terms of the amount of numbers we have here now, when the first dice is even in this row, well, in this column, there are 6 numbers even again. 6 numbers even. So 6 numbers. So when the first dice is even, we have a sample space of 18. So the probability of F given E, we already know its denominator is 18. The sample space is 18. Alright? Since for the first die to be even, have an even value, it has to be either 2, 4, and 6, 2, 4, and 6, or 2, 4, and 5. And in each of these columns you have 18. Now we want the amount now that's, remember F represents when the total is less than 9. So F represents the event that the sum is less than 9. So from these 18 numbers, let's look at the amount of them that's less than 9. So less than 9, well, less than 9. So there we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 values that are less than 9, and we can even reduce it by dividing by 6. 12 divided by 6, that's 2. 18 divided by 6, that's 3. So the answer there is 2/3 for F given E. And part 3, we are asked to determine whether the two events F and E are independent. Alright? So if independent, we know that if independent, the probability of F intersect E is equal to the probability of F times the probability of E. So we need to find all these probabilities and see if this equation holds true. Alright, let's do the probability of F intersect E. When both these things are occurring together. So F and E, that's F, that's the event that the sum is less than 9 and it's even. So let's go again. We already did it already. It's actually 12. But we're taking it from the entire sample space now. So F intersect E will be actually 12 out of 36. Alright, since the entire total amount of numbers here is 36. And it's not conditional. So we're taking 12 out of 36. So don't forget F intersect E is different from F given E. F given E is the assumption that we already know the numbers. The number on the first die was even. This is from everything now. 12 over 36, which is 1/3. Alright, the probability of F, the probability of F, probability that a number is less than 9. We can count all the numbers that are less than 9. So less than 9 would be in the first column, that's 6. Second column, another 6 again. So that's 12. Third column, 12 and 5, that's 17. Fourth column, 17 and 4, all the numbers less than 9. That's 21. And less than 9. 21 and 3, that's 24. Less than 9. 7, 8, that's 26. So 26 of these values are less than 9. And that's 26 out of 36. And then the probability that's the first E is the probability the first die is even. And of course that should be 18. We already have that. If the first die is even, 2, so we have 6 values under the 2. 6 under the 4. 6 below the 6. And these are when the first die is even. Each of them have 6 totals. That's 18. And it's out of, so it's 18 out of 36. So probability E, that's 18 over 36. Or half if you should reduce it. Now if we should calculate the probability of F times the probability of E. No, so I'm not calculate this. So the probability of F times the probability of E of F is 26 over 36. This reduced to, if I divide 2 by 2, it's reduced to what? 13 over 18. That's 13 over 18 times the probability of E. That's a half. That's 13 over 36. Notice it's not equal to F intersect E. It's not equal to F intersect E. Therefore, E and F and E are not independent. Alright, so therefore, F and E are not independent. Alright, so that's our solution there. Let's move to part B. A system of linear equations is given as, and we have a system there. By representing the system of equation as an augmented matrix, show that the system is inconsistent. Alright, so we are asked to use b equal to 2. Alright, so we're going to rewrite form a matrix here. So using the coefficients for the x, that's 1, 5, and 2. For the y, that's 1, 3, and 1. For the z, that's minus 1, 1, 1. And then on the other side, we have minus 1, 3, and we actually use b as 2. So we're going to use Gaussian elimination. Alright, so we need some zeros to lead our second rows. So I'm going to change row 2 and row 3. So I'm going to let row 2 will become row 2 minus 5 row 1. Since if I subtract 5 from this, I get a 0 here. And row 3 will become row 3 minus, we can subtract 2, right? Minus 2 row 1. Alright, so continuing. So row 1 will not be, the one will not be disturbed. Alright, so 1, 1 minus 1. I'm disturbing row 2 and row 3. So row 2 is row 2 minus 5 row 1. So it's 5 minus 5 of this corresponding number here. So it's 5 minus 5 times 1. That's 0. So it's 3 minus 5 times 1. That's minus 2. And 1 minus 5 times minus 1, which becomes 1 plus 5. That's 6. And 3 minus 5 times minus 1. That's 8. Let's do row 3 now. So row 3 is now row 3 minus 2 times row 1. So it's 2 minus 2 times 1, that's 0. So it's 1 minus 2 times 1, that's negative 1. That's 1 minus 2 times negative 1, that's positive 3. And then it's 2 minus 2 times negative 1, and that's 4. So let's continue. So we can change now, attempt to change our row 3. So row 3, to get it a 0 here, row 3 would be row 3 minus, so minus 1 plus 1 will give you 0, right? So to get a plus 1 here, that multiplies by a negative half. So row 3 minus half of row 2. So we're going to have now, end up with, this we're going to become now, so again, here now we're not troubling row 1 and row 1 and row 2, right? So 1, 1 minus 1 minus 1, 0 minus 6, 8, just row 3 we're disturbing now. So is row 3 minus half of row 2. So 0 minus half of 0, which is 0. Negative 1 minus half of negative 2, that's negative 1 plus 1, which is 0. And it's 3 minus half of 6, is 3 minus 3, 0. And 4 minus half of 8, that's 4 minus 4, 0. So actually, infinitely many solutions. So this is saying that, remember this is x coefficient, y z. So this is saying that 0x plus 0y plus 0z is equal to 0. Which means that no matter the values of x, y, and z, this equation will always hold true. Because you multiply these by 0, you're going to get 0. So this is a situation where we have infinitely many solutions. Infinitely many solutions. So there's an error here. If your system is inconsistent, it means that it has no solution. But we have many solutions. So, I mean, the person who set this paper obviously made an error there. Alright? Now, in part 2, by letting b equal 4, solve a system of linear equations. So again, we're going to do the exact same thing we just did a while ago. This time now, we're going to replace the b with 4. Alright, so let's form our matrix again. Everything will be the same except we'll have a 4 instead of 2 for that bottom right value there. Alright, so let me just go again. So we have, so the matrix would be 1, 1, negative 1, 1, 1, negative. Let me just go again. So it'll be 1, 1, negative 1, negative 1. In the second row, we'll have 2, 3, 1, 3, 5, 3, 1, 3. So 5, 3, 1, 3. And in the final row, we should have 2, 1, 1, 4. Since we're letting B before now, so it's 2, 1, 1, 4. So 2, 1, 1, 4. Alright, let's apply it again. Alright, so we're doing the same thing all over again. Alright, so again, we're changing row 2 and row 3, right? So row 2 will become row 2 minus 5 times row 1. And row 3 will become row 3 minus 2 of row 1. Alright, so row 1 will not be disturbed. Just row 2 and row 3 we are troubling, alright? So minus 1 and then 1, 1, minus 1. So again, what did it already? So row 2 minus 5 of row 1. So it's 5 minus 5 times 1, that's 0. 3 minus 5 times 1, that's negative 2. 1 minus 5 times negative 1, that's 6. And 3 minus 5 times negative 1, that's 8. And then, again here, row 3 is now row 3 minus 2 times row 1. So 2 minus 2 times 1, that's 0. 1 minus 2 times 1, that's minus 1. 1 minus 2 times minus 1, that's positive 3. And 4 minus 2 times negative 1, that's 6. Right, let's continue now. Let's attempt to change row 3 now. So row 3 will now become, row 3, say minus half of row 2. Alright, so what we'll end up with now is, so just troubling row 3 this time. So row 1 and 2 will remain as they are. So 0 minus 2, 6, 8. So row 3 is row 3 minus half of row 2. So 0 minus half of 0, that's 0. Negative 1 minus half of negative 2, that's 0. That becomes negative 1 plus 1, 3. Minus half of 6, that's 3 minus 3, 0. And 6 minus half of 8, that's 6 minus 4, which is 2. So remember, these are the x, y, and z coefficients. So this is saying that 0x plus 0y plus 0 times z equal to 2, which does not make any sense at all. 0 times a number plus 0 times a number plus 0 times a number should give you 0. So this is just not possible. So not possible. Hence, the system has no solution. When B is 4, system has no solution when B is 4. Alright, let's move on. Part C, a counting problem. Use the letters of the word isosceles to answer part C, 1 and 2. Calculate the number of ways in which the letters can be arranged if the E's are separated. Now, the question was not clear in terms of the number of distinct ways, but I'm going to assume it's the number of distinct ways you're speaking, alright? So isosceles, this word has how many letters now? So let's count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 letters. So we have 9 elements, but some of them are the same. So we have 9. So let's well, the number of ways in which the letters can be arranged if the e's are separated. No, alright? So number of ways, total number of ways, alright, whether the e's are separated or not, would be, well, there are 9 elements, so it's 9 factorial. And we have some repeat. Notice the s. We have s is there 3 times, so 3 times, so that's all divided by 3 factorial. And we have 2e, so also divide by 2 factorial. And we can punch this in our calculator. And it should get 30,240 ways. Alright, so that's the total number of ways. Alright, let's do the total number of ways. So number of ways with the e's together. No, if you look at, if we have the e's together, so let's say, so we have isosceles, so we have I, so say, we're going to put the 2 e's together now, e, ls, and there's also a c, right? Let me write it, leave off the c, iso, c, we have a L, we have a S. Let me put the 2 e's together as a 1 block. Alright, so I'm going to put the 2 e's as 1 block. So if I separate these, what we have here is that 1, 2, 3, 4, 5, 6, 7, 8. So now we'll see it as 8 elements, since we group the e's together. So let's view it as 8 elements. So right now what we have is actually, number of ways is actually 8 elements. 8 elements now. And of course, 2 of the s's, and we'll talk about distinct ways. So these 3 s's, alright, so divide by the 3 factorial. Alright? So this will be 8 factorial divided by 3 factorial, that's 6,720. And then the number of ways the letters can be arranged if e's are separated. So we have a total number of ways, and total number of ways when the e's are together. So to answer the question, alright, number of ways with the e's not together, so with the e's separated or not together, then that's equal to the total number of ways minus the number of ways where we have the e's together. And we can do that, subtract, and we get 23,520 ways. Part B, well, part 2. In how many ways can 4 letters be chosen from the word so that at least 1 vowel is included? Now again, we can do the exact same approach. So I'm going to just rewrite the word again. So it's iso, say, these. And again, it was 9 elements. Alright, it was 9 elements. Normally, ways can 4 letters be chosen from the word so that at least 1 vowel is included. Alright. So we have 9 elements, and we want to find the number of ways we can choose the vowels. Now, the vowels are I, O is a vowel, E, E. So we have 4 vowels, and let's do it with, so let's do no restrictions. So 4 vowels. So we have, so total number of ways we can choose. So number of ways, we can choose 4 letters. With the vowels. And of course, we have 4 vowels. So that would be 9 choose 4. Alright, and you can enter this in the calculator, or you could say 9 factorial over 9 minus 4 factorial. Times 4 factorial. Either way, 9 choose 4 work out to be 126. So the 126 ways we can choose those 4 vowels. Let's work out the number of ways now we can choose no vowel. So number of ways we can choose no vowels. Now if we look back at the word isosceles, choosing no vowels, which would mean that you're choosing from the consonants. And the consonants here are, so we have 2 S and S. That's 2 of them. C is another one. That's 3 consonants so far. And we have L and S. So we have 5 consonants. So to choose no vowel, we have to choose from these 5 consonants. So that we have 5. We're choosing 4, and of course none of these 4 will be vowels. So 5 choose 4, and 5 choose 4 is just 5. So the answer to the question, and the question was to find the total number of ways 4 letters can be chosen from the word so that at least 1 vowel is included. So the answer will be the total number of ways, solution, total number of ways minus number of ways with no vowels. So the total number of ways, that was 9 choose 4, since isosceles has 9 elements, we're choosing 4, and that came to 126. The number of ways we can choose to get absolutely no vowel, we'll be choosing from these 5 consonants in the word. That's 5 choose 4, that's 5, so the answer would be 121 ways. Let's move on to the final question, question 6. Determine the general solution of the differential equation, and we are given the equation there. So we are going to use the first order inseparable, so we're going to use the integrating factor method, which means we need dy by dx by itself. So we're going to divide each term on both sides by x. So divide by x, divide by x, divide both sides by x. So what we're left with now is x cancel x, so we're left with dy by dx minus 2 over y, 2y over x equal to x cubed divided by x, that's x squared sine x. So the integrating factor, write it abbreviating IF, is equal to the integral e to the integral of the coefficient of the y, and the y coefficient here is negative 2a. So the integral of negative 2 over x dx, which is equal to e, and the integral of 1 over x is log x. So this is negative 2 times log x, which is equal to e, and we know the laws of logarithm. This is ln x to the power of minus 2. So e to the log x minus 2 is same thing as x to the power of minus 2, or same as 1 over x squared. So we're going to times both sides by the integrating factor of 1 over x squared. So we're going to times both sides of the equation by 1 over x squared. Alright, so 1 over x squared times dy by dx, that's 1 over x squared times dy by dx. 1 over x squared times the next term, so it's 2y over x, multiplied by 1 over x squared. And then 1 over x squared times the right hand side. So we have x squared sine x times 1 over x squared. Same as dividing by x squared, right? So here what we have, x squared cancel itself. So we're left with sine x. On the right, we have 1 over x squared dy by dx minus 2y over x cubed. X times x squared is x cubed, so it's 2y over x cubed. Now we're going to integrate both sides with respect to x. Usually the right hand side is just integrate sine x, that's negative cos x plus c. And the right hand side is always y times the integrating factor. So it's always y times the integrating factor, which is 1 over x squared. So it becomes 1 over y over x squared. And then you're solving for y, so you can multiply both sides by x squared. So I multiply the left hand side by x squared, I get y. And I multiply the right hand side by x squared, I'll get negative x squared cos x plus c times x squared. So that would be your solution. Part B. So in part D, there we have a second order differential equation. We can form a characteristic equation here. Second derivative, so that's m squared plus 3m, plus using the coefficients, plus 7 equals 0. Now this cannot be factorized, so we have to solve it using the quadratic formula. Minus b plus or minus square root b squared minus 4ac upon 2a. So m minus b is this 3, so minus 3, b squared, which is 3 squared, that's 9, a is 1, c is 7, so negative 4ac is negative 4 times 1 times 7, that's negative 28, all upon a is 1, all upon 2 times 1. So this becomes minus 3 plus or minus, well, 9 minus 28, that's 19, negative 19, that's the square root of negative 19 over 2, which is minus 3 plus or minus, well, square root of 19, negative 19, that's rewrite it as square root of 19 times I, times square root of 1, negative 1, and of course the square root of negative 1 is I. So this becomes 3 plus or minus, root 19 times I, all over 2. So if we separate this, this will be 3 over 2 plus or minus root 19 I over 2. Now the complementary solution, since the roots are complex, the roots are some complex numbers there, so it's normally the format is y equal to e to the ax into cos bx. Well, c1, where c1 is a constant also, and c2 is another constant, sine bx. And what's a and b? Of course, a is a real part of the complex number there, and b is the imaginary part of the complex number there, right? So a and b are the are parts of the complex number, real and imaginary, respectively. So we have is E and A, so 3 over 2. Well, negative 3 over 2. So remember, negative B is negative 3, so negative 3, negative 3. Alright, so negative 3 over 2 x into C1 cos and B is the imaginary component, which is root 19 over 2x, so which is root 19 over 2x plus C2 sine B, and B is root 19 over 2 x. That would be our solution. Second part, show that the particular solution of the differential equation is, and we are given. Alright, to tell us what the answer is just for us to show it. Now if we go back up, here, alright, we're told that can let y be equal to ax squared plus bx plus c, since the form here on the right hand side is a quadratic form. Alright, so we can let y be equal to ax squared plus bx plus c, which means y prime, that's the first derivative. Differentiate ax squared, multiply by the x power, you get 2ax. Differentiate bx, you will get b. Differentiate the constant, you will get 0. The second derivative, differentiate 2ax, you will get the constant 2a. And we can substitute these now into, remember, let me just rewrite the function here. Remember that. So this, remember this, the second derivative plus 3y prime plus 7y. So the second derivative plus 3y prime plus 7y was equal to 4 minus x squared. Right? Was it 4 minus x squared? 4 minus x squared, alright? So we can substitute it. So we know that the first derivative, to substitute this, the first derivative was 2a. Sorry, second derivative was 2a. Plus 3 times the first derivative was 2ax plus b plus 7 times y, and y was so 7 times ax squared plus bx plus c equal the right hand side, which is 4 minus x squared. Alright, so on the left hand side, let's expand and equate coefficients now. So on the left hand side we have 2a, 3 times that, that's 6ax, 6 times b, 3 times b, that's 3b, plus 7ax squared, plus 7bx, plus 7c, equal to 4 minus x squared. Alright, so let's equate coefficients now. So we can equate coefficients for the x squared terms. Now for the x squared, if we look at for the x squared terms, on the left hand side, the x squared coefficient is 7a. On the right hand side, the x squared coefficient is negative 1. So divide both sides by 7. A is equal to negative 1 over 7. Let's do coefficient over x. On the left hand side, the x coefficient, we have a 6a there. We have a 7b here. Any others? No? So 6a plus 7b. On the right hand side, there's no x term, so there's no x coefficient. So the x coefficient there is 0. Now we already know that a is negative 1, 7. So 6 times a is actually 6 times negative 1, 7, which is negative 6, 7, plus 7b. equals 0, which means that 7b equal positive 6, 7. And if we times both sides by 1, 7, to solve for b, we can times both sides by 1, 7. So it's 1, 7 times 7, that's b equal to 6 over 49. And finally, we can equate the constants. So on the left hand side, and this is for x. We just did. And now for the constants now, on the left hand side, we have 2a plus 3b plus 7c. And the constant on the right hand side is positive 4. And we already found the value of a and b, so we can plug them in. We already found the value of a is negative 1, 7. So 2 times a, that's 2 times negative 1, 7, that's negative 2, 7. We know b is 6 over 49. So 3 times b is 6 over 49. So 3 times b is 3 times 6 over 49. That's 18 over 49. Plus 7c equal to 4. So we can group all the terms on the right hand side here. So we have 7c is equal to 4. Bring these terms over. That's plus 2 over 7. Minus 18 over 49. So simplify the terms on the right. We get 7c equal to 192 over 49. So we can times both sides by 1 over 7 to solve for c. Times both sides by 1 over 7. So 1 over 7 cancels 7. So c would be 192 over 343. Alright, so we have values for a, b, and c. So it means therefore that y, particular solution, we just found it. Y, remember y we said it was ax squared plus bx plus c. Let's put in the values now. So we have for a negative 1/7. Alright, so negative 1/7 x squared. We have for b 6 over 49. So plus 6 over 49x. And we have for c 192 over 343. And the final thing, the general solution, now we put the two of them together. So the general solution is the complementary plus the particular. The general solution is y, so a complementary function plus the particular solution. So we just sum them. And the complementary function was y equal to e. It was e to the negative 3x over 2 cos root 19x over 2 plus c2 sine again root 19x over 2 plus our particle solution we just found. And that's it. And that's our paper.